A key to dilution is this. You have one compound of interest, and molarity and volume. Are they changing or not changing? Molarity and volume for dilution. Molarity and volume for a dilution are both changing. Okay? For, you might, if you're thinking they're not changing, you might be thinking of a unit conversion sort of question. So you'd have something like this. Say 6 molar of some acid, HCl. It doesn't have to be an acid, I just picked an acid. And let's say there's 100 milliliters of it. And then I say I'm going to add 300 milliliters to that solution here. And I want to know what's the new molarity. Well, you can see the volume's changing and the molarity has to be changing. So you're going to use M1V1 equals M2V2. Well, the first molarity is 6. The initial volume is 100. And then the final molarity, that's what I'm trying to find. I don't know what that is. The final volume is what? Yeah, not 300. I added 300 to 100, so it's 400 in this example. So you can do a little math here. I quadrupled the volume. That means the molarity has to go down by 4, so that'd be 1.5 molar. Let's look at a couple things. The molarity is what units? M, capital M means moles per liter. Is it okay that I have milliliters? Yeah, because they're both the same. As long as both sides are the same unit, it's totally fine. Am I okay with 2 sig figs here? Yeah, because of that 6 here has 2 sig figs, so that's totally fine as well. We're good. All right, yeah, that's it. That's a typical question. Okay. There's dilution. Now let's do a titration. That's in the same kind of family of problems. It's really just a stoichiometry problem. Whenever we're talking about titrations, you'll have some reaction. Let's say HCl plus strontium hydroxide. And let me write out the products for us. There would be strontium chloride. This would be what kind of reaction, by the way? What kind of reaction will this be? I haven't finished writing it. Yeah, it's generically called a double replacement, but specifically it's what subset? Neutralization, yes. Acid plus a base goes to a salt or an ionic plus water. Okay, so let's balance this. There'd be a 2 here. That one's good, a 2 there. That should do it. Okay, and then what would happen is, let's say I say this is 2 molar, and let's say that's 100 milliliters. And let's say this is whatever, it's 10 milliliters, for example. What's the molarity here? That could be an example question. So what you're going to do, you start with the specified side. You're going to change this to moles, stoichiometry. Step 1, moles. Step 2, molar ratio. And step 3, go to what they asked for, where molarity is moles per liter. So 3 steps in any stoichiometry problem. Let's do those 3 steps right now. So first, go to moles. Step 1. So I know 100 milliliters times 2.0 moles per liter. In the last problem, I didn't have to convert this to liters. How about this problem? Yes, definitely. And there's other ways to get around that, but the way we've been doing it, you would have to convert. 1 liter is 1,000 milliliters. Okay, that's step 1. I've gone to moles. Notice that the milliliters are gone, liters are gone, and I'm left with moles. That's step 1. Step 2, molar ratio. Oh, by the way, I know this is a titration for a couple reasons. 1, you might see the word titration in the problem. But 2, and there's a reaction involved, and there's more than 1 molecule of interest. In this case, there's 2. Okay? Usually, those are both reactants in a typical titration, which is this is pretty standard, normal titration problem right here. Okay, so that's how I do is titration. Forgot to say that earlier. Okay, molar ratio now. This is step 2. There's 1 mole of the strontium hydroxide for every 2 moles of the HCl. I gotta stop that from balancing. Then step 3, the last step, I'll write down here. I don't have space. Well, let me erase that for a second. Okay, step 3. Right now I have moles of strontium hydroxide. Let's cancel these moles here. I have moles of strontium hydroxide. Notice I need to get to moles per liter, so I need to go to that. So what would I do right now? I divide by which liters? The 10, yeah. So let me get a different color pen. I'll do this in brown. Divide by the 10 milliliters. Would that get me to the right answer? No, I have to convert 1,000 milliliters per liter. Okay? I just made this problem up so you can figure it out at home. Okay, but that's the math here. All right, so there's a titration. Any questions on that? It's just stoichiometry, that's it. Okay. Okay. Move that up. Let's move on to simultaneous reactions. Cancel that out. Simultaneous reactions, or consecutive reactions. I think I have an example of that one for you as well. Let me pull it out of here. Yes. I don't think I did this problem for you. Is that correct? Looks new. I believe I have not done this before. I like this question because recently I've been on this kick of putting the simultaneous reaction problem as a multiple choice. That just sounded cool to me. So often you'll see the last couple years, the simultaneous reaction has been a multiple choice problem. Okay? Doesn't have to be, just one way of doing it. Okay, so how does this work? Let's zoom in here. Here's the overall reaction, and here's a set of 3 simultaneous reactions. Couple things to remember. The intermediate appears in the simultaneous, but not in the overall. So what's an intermediate here? C2H4, is that what you said? C2H4, is that an intermediate? No, it appears in the overall. F2, is that an intermediate? No, it appears in the overall. H2, that's an intermediate. Don't see it in the top reaction. Any other intermediates? C itself, the carbon, is not in the overall. Those are both intermediates. I have 2 strategies to solve these kind of problems. Strategy 1, and I usually do this first. I start with the overall, and I match it to what I see in the consecutive reactions. Step 2 is to cancel out intermediates. So I'm going to start with strategy 1, and let me give you the page in the reader, in case you're following along in the reader. It's in the simultaneous reaction section under the solving method, in this folder on page 33. Okay, so here's what I'm going to do. Strategy 1. I'm going to find something in the overall that appears only once down here. So let's try, I'll put a circle around C2H4. It appears once in the overall and once in number reaction 2. Okay, there's 1 in the overall on the left-hand side. This second reaction must match that. So what must be beta, or the multiplier here? -1 will flip the reaction over just like in algebra, and that'll put 1 C2H4 in the reactant. So that'll cause it to match. Remember, when I have a multiplier, I won't ever change that multiplier unless I think I've screwed up. Okay, now I'm going to use, let's use brown. Okay, let's see. Would I check out F2? Is that a good one to look at? No, because it appears a total of 3 times. That's too much thinking. How about CF4? Okay, people are changing their mind. Yeah, CF4 appears a total of twice. So that's a good one to look at. I want things that only appear twice. Okay, so remember, the top reaction is what I want. I want 2 CF4s, or tetrafluoromethanes, in the products. So what was my gamma multiplier? -2. The negative flips it over to put it in the products, and the 2 matches it with the 2 in the overall reaction. Okay, now I don't need to change this third reaction. That second and third are set. Now I'll use blue. Let's see, can I use HF? Yeah, that looks good. I guess a triangle? I don't know. Out of shapes here. Triangle. Oh, that's not good. All right, whatever. So I need 4. I have to, so I'm going to multiply by 2, right? Okay. Now, do I need to do anything else, or am I done? I mean, besides circling the correct answer, which is D, I'm done. If you're nervous, you can double check your answer. So for example, what did we say was intermediate? C is intermediate. Will C cancel? Yeah, there's negative, on the second reaction, there's -2 on the left. On the third reaction, there's -2 on the right. They cancel. You can check the other intermediate, which was, I forgot what it was, H2. Does that cancel? Yeah, on the first reaction, there's 2 on the left. Second reaction, there's -2. That cancels. So you can just double check everything if you're nervous. I would personally, if I was doing this problem, I wouldn't double check. I would just circle D, and I would come back to this problem at the end and double check it. Okay? Just to save time, just in case I'm out of time. At least I've got something circled. I'm not wasting time double checking. Do all your double checks at the end is my recommendation. Okay, any questions? Moving on then. Yeah. Say it again. How did I know that beta and gamma were negative? Because beta, notice I need this to be on the left. I need that to be on the left. So negative flips it over. This one, I need it to be on the right. So negative flops it over. It would just be as if you had x equals 7. If you multiply by -1, that means negative x equals -7. Is that okay? I add to both sides. It's the same as that. So negative flips it over. It's just that output. Okay, moving on.